When you're dealing with a linear system, in this case, we're going to talk about two variable, two equation to start with. You have the following. I'm going to work this the same way as I would with this example and explain to you where the coefficient matrices and all that stuff comes from this sample. So if you're dealing with a system of equations like we have in the past, 2x plus y is 1, 3x minus 2y is negative 23. We would normally set up a system of equations, and in this case we might use some linear combination or substitution to solve for x and y. Do you agree? Sure. Well, now we're going to throw a third way to solve systems in. This way is using what's called Cramer's rule. Now, you will find out that Cramer's rule is a little tedious for 2x2s. It takes a little bit of time, but it's very easy to see how it works with the 2x2. Cramer's rule is great for anything larger. 3x3s, 4x4s. Using Cramer's rule is a piece of cake to solve systems. Now, in this case here, if I wanted to create a coefficient matrix from that example, all I'm doing is taking the coefficients from the problem. 2, 1, 3, negative 2. You agree? Yeah. The coefficients from here. So the coefficient matrix here would be 2, 1, 3, negative 2. What are you going to forget? The negative. You're going to forget the negative. Careful, don't forget the negative there, okay? So you get a coefficient matrix. Now, what happens here is that we can take this coefficient matrix and we're going to find its determinant to start with. Okay, so we had that example. There's still our first example. It was 2, 1, 3, negative 2. Then what I want to do is find the determinant. 2x2 determinants, remember, very easy to find. The determinant is going to be 2 times negative 2 minus 3 times 1. Negative 7? Oh, excuse me. Yeah, negative 7. 2 times negative 2 minus 3 times 1. 4 minus 3. Negative 4 minus 3 is negative 7, right?
Yes.
Go down then up.
No,
When you're working with more of them, when the 3x3 you have to add all those together. When you have a 2x2 it's just down and up. That's all it is.
yeah,
I'm not dividing. No. I'm not. We're not. Don't even worry about this right now. We're not doing anything yet. All I did was just find the determinant. All I did was find the determinant, right?
Yeah.
Okay. Now, what we use the determinant for is that you can solve the full system by finding another determinant and dividing them. Here's what happens. Do you guys agree that the 1 and the negative 23 kind of make their own 2x1 column matrix? If I put them like that?
Yeah, sure.
So if I wanted to solve for x, now granted, remember, 2x2 systems are always much easier by linear combinations because it's quicker. It's just very easy to show you how this pattern evolves using Cramer's rule this way. If I want to solve for x, what I do is I take that column, 1, negative 23, and I put them in for the 2 and the 3. Now, I keep the y column that was already there. Move this over.
Is there a certain reason it's the 2 and 3?
Because that's the solution part. Because what I'm doing is I'm trying to solve for x. So if I'm going to solve for x, I take this column and I replace it here. All right?
So you should put 2 and 3 right there?
No. I'm going to find another determinant. Negative 2 minus negative 21, or 23. Right. 1 times negative 2 minus negative 23 times 1.
Where did you get 1 and negative 2? Or why is that?
I've said it a couple of times now. I've taken that answer column and putting it in for the x column. This is the x column, this is the y column. Okay? The coefficient from the coefficient matrix. All right? Since I'm solving for x, I take the solution, I put it in that column. Find that determinant. It's 21. Divide it by the original determinant of the problem. X is -3. It's another way to solve systems. I do the same thing to solve for y. Instead of solving, when I'm solving for y, where do you think I put the answer column in then? On the y side. So I continue to go back to the original matrix. I have determinant of 2, 3. I want to put my answer column in for y now. And then I'm going to divide that by that original determinant, that -7. Okay? Get the determinant for the y value. You get 3 minus -46. Otherwise known as 49. So the solution set is -3, -7. Granted, when you see a 2x2 matrix, 2x plus y is 1, 3x minus 2y is -23. You're probably thinking right away, very easy substitution or something.
But aren't you supposed to do 2 times -23 and then minus 3 times that?
I did.
Would do easy.
Oh, I did. I went the wrong way. Thank you. Sorry about that. I went the wrong way. Okay. I will. I'm going to walk you through it again. I just wanted to show you how this evolves. What we wind up doing here, when we're working with determinants, you're able to create a matrix coefficient, or a coefficient matrix. You have your x and a y. So in our original part, we had 2, 1, 3, -2 equaled 1, -23. To solve for x, you take the answer column and then the y column divided by the original determinant. Okay? And you're finding the determinants of all this stuff. And remember, 2x2 determinants are something that you can do by hand. They're really fast. The y value then is going to be the x column, and then the answer is in here over the original determinant. You do a couple 2x2s real fast, real easy. When you get to the 3x3s, it becomes a little bit more tedious. You've got to find all those extra determinants. So at that rate, when you start doing 3x3s, am I going to be having you crank those out by hand? There's buttons on your calculator. When we get into 3x3s, it's just, we might as well just use our calculator. 2x2s, we can do those by hand. Okay?
What, you can't use a calculator?
You can, but remember, I want you to be able to do this by hand. Let's try another one. Very, very simple example. I have 8x plus 5y equals 2. 2x minus 4y is -10. That means that coefficient matrix is going to be 8, 5, 2, -4. The determinant of that is going to equal -32 minus 10 to get -42. Do you agree on that? Now, when I go to solve for x, what do I put in for the x column now in the matrix?
2 -10.
2 -10, good. Go back to the same y's. That determinant is -8 minus -50. and I get positive 42. You agree?
Yeah.
Divided by negative 42. You get x is equal to negative 1. We do the same thing to solve for y. Now I put my answer column in for y. 8 and 2 for the x column. Negative 80 minus 4. You get negative 84. Divided by negative 42. Now do you see why we can use determinants? It's 8, bless you, 8 times negative 10 is negative 80. Negative 80 minus 4 gives you negative 84. Do you see how a 2 by 2 is very easy to do this by hand? When you get to a 3 by 3, you have to find all those extra determinants. Are we going to do 3 by 3s by hand? That's mean. Let's try another one for yourself. Pick a number, 1 through 3.
3.
Two.
No, do this one. Did you guys get the original determinant to be negative 37? Yeah, everybody got that okay? The first one from the matrix. When you do the negative 16 minus 21, are you still going up first?
No, I missed the negative. That's negative.
Now when I go to solve for x, put your answer column in. Is it 185 or something like that?
Yeah, negative 185.
Divide that by negative 37. I thought it was positive. I thought that first one. I just did it.
It's positive.
I thought it was positive.
It's positive.
Yeah, it should be positive. The determinant there should be positive. Positive 185.
So, wait, negative 180. That's here. 185.
I found the determinant. 21 minus negative 23 times 7,
Negative.
which is 164.
It's 24.
20.
21.
Oh, thank you. That's how you get the 185. Okay. Divide that out, you get negative 5. And then to solve for the y value, you replace the y column with the answer. Not always. Not always. Yes, you can, but when it says solve it using Kramer's, make sure you show for both ways. Especially if I'm going like 2 by 2 stuff like that.
Like on a test?
Yeah. I want you to show the step. That's all. Because I will have that on a test if you crank this out by hand. 2 by 2. And then for y, did you guys get negative 1?
I just got
No,
plus
that's
one.
Oh, that's right. Negative. Yes. Yeah, it was negative 37 over negative 37 when you substitute that through. Okay. Now, 2 by 2s, like I said, very, very, very simple to do by hand. Let's look at a 3 by 3 example and show what's different. Really nothing. All you're doing is adding another row and another column. Then you just have to press buttons in your calculator. Okay? So here's what we do. In a 3 by 3 setup, let's just start with this example. We'll start with this example. We have, for the first equation, x plus 2y minus 3z is negative 2. The second equation is x minus y plus z is negative 1. And last but not least, 3x plus 4y minus 4z is 4. So the first thing we want to do is find the determinant of the coefficient matrix. Now, do you want me to write out what the coefficient matrix looks like, or could we just enter it directly into our calculator to get the determinant?
Do it, calculate.
All right, let's go right to our calculator. I'm going to slide this over a little bit. Should be enough room. That should all show up, right? Yeah. Remember, to get to the matrix, hit alpha, zoom, and now we're dealing with a 3x3. And we get that right away. Let's put in our coefficients. 1, move to the right, 2, go right, -3. If you hit right, it'll drop you to the next row. Okay. Now I want to find the determinant of that. I should have put determinant in front of the matrix, shouldn't I? Get out in front. You'll have to go all the way back. I apologize. If you move, there's more than one way to do this. If you move your cursor where it's blinking on the matrix bar, hit second, delete, and that's the insert button. Now we hit our math. DEL.
So second delete is insert.
Yeah. And now I just threw determinant in front of it.
Wait, how did you get the determinant?
Second matrix, and move it over one spot. Okay? Hit enter. Determinant, second matrix. Move it over one spot to the right. And hit enter. You see it? Second matrix, move it over to the right one. There, you didn't move over to the right one, that's fine. Now hit enter. There's your determinant, -7. Everybody get -7? Yes, sir.
Do you have more of those calculators to check out?
Yes. Okay, you don't have that? Oh, because of the yes, yeah. I'll get you one. If we hit enter, do we all get -7? Yeah. Cool. Here's one thing I would do. When I'm working with 3x3 problems, we all agree that we're going to have to divide matrices by, or determinants by -7, right?
Yeah.
I would write that down. Write down -7. That way you know you don't have to continually re-enter it. So now it's just a matter of going back to your entry. And you guys know how to overwrite data?
Wait,
I hit second answer, or second entry, excuse me.
it's going to be, wait, how'd you get to pop up?
Second enter. Now what I'm going to do is just go back in here, and in order to solve for x, I have to overwrite the x column, correct?
Yes.
X, Y, Z column now. So instead of being 1, 1, 3 in the column, it's going to have to be -2, -1, and 4.
So for all three of them, you just substitute,
Yeah,
and you'll get all three answers.
-2. You'll have to do this 3 times.
Better than,
Yeah, it's better, much better than doing this by hand.
0.
Okay. Now in this case here, when I change that column, my determinant's going to change. I get 0. So what's the value of x? It's going to be 0. So I know in this case, by using my calculator, x is going to equal 0. So now I go back to the calculator. If I'm going to solve for the y column, or solve for the y's, where do I put the answers in now?
It's the y column.
In the y column. But what do I have to do that x column?
You have the x.
I got to change it back again. So you see how this gets just a little tedious. You just got to press buttons on your calculator, but it's sure better than doing it by hand, isn't it? So go back again to overwrite. Remember, second enter.
You have to go back, don't you have to go back up to the first determining step?
You don't have to, because if you just go second enter, you just have to overwrite 2 columns now.
But now don't you have your answer column in one of them? And
Yeah,
then
I'm just gonna change. I'm just gonna change it all up. I'm just gonna change my first column back to 1. Oops.
Oh, it's easier to just go back up to,
I mean, you can.
yeah.
I mean, it's up to you how you want to do it. I'm just going this way. 1, 1, 3. 4, -1. It's gonna be 9. It's almost close. And in this case, we get -35. And what was our original determinant again?
-7, so you
What's
get
-35 divided by -7?
5.
And I'll let you guys do Z. Doesn't this make solving systems of equations a lot easier? I got scrunchy face. You okay? Oh, I wasn't. I didn't notice you had scrunchy face, but are you okay too? Not that I would want to ask if you're okay. Okay. It happens.
That's why Z.
What'd you get for Z? Anybody else get 4? Then you did it just fine. When you go to put your Z value in, you keep the original for X and Y column, put your answers in for Z, and you do the same method. Okay? Does everybody see how this is a very easy way to do systems? I mean, this isn't the world's worst system of equations, but now you can start to do a lot more scary stuff. For example, we can start with a simple word processing. Now, we're going to use some chemistry stuff. I don't even know what this stuff is. What they're talking about atomic weights. I guess that's how much things weigh at the atom level. I'm guessing. I wasn't very good at this chemistry thing. Now, if I'm looking at this setup, they're giving you 3 formulas. How many different variables do you see? 3 of them. A C, H, and an O. Was that carbon, hydrogen, and oxygen?
Yes.
Okay. Not bad, huh? So if I'm going to write this out in terms of equations, what I'm going to do is that there's subscript. That means that there's 4 hydrogen, right? 3 carbon, 8 hydrogen, 3 oxygen. That's what those mean?
Yeah.
So in terms of math, I would write this as, this first equation would be a C plus 4H is 16. 3C plus 8H plus 3. Can I use X for oxygen? Is that okay?
No.
Or do you want me to just use O? I mean,
I'll use X, because I hate
and that's 92. And what you're doing here is you're going to solve for what the atomic weight for each one of these atoms is. 2H. To be honest with you, I still think that a system like this, since it's missing variables in a couple of the equations, is quicker to do by hand. But I'm showing you how you can interpret a data chart to solve a system. You can use Kramer's rule now to solve this. You find the determinant of the original matrix. Now, what do I put for my coefficients for x in the first equation? 0, because there's nothing there. Same thing here for 0 in the last row. So my determinant, original determinant, would look like this. Let's slide this up some. I find the determinant of 1, 4, 0, 3, 8, 3, 0, 2, 1. And when I find that determinant, you guys have calculators, right? It's so much easier to use a calculator than the one before. -10?
Yes.
Thank you. And now could you move that column over, find out the rest of them? Not so scary, is it? Go ahead. Take a second, see if you get it. I'll try it too. Did everybody get that? 12, 1, 16 respectively?
Yeah.
Aren't you glad I didn't show you how to do this before? I know, wouldn't you much rather do this by hand? Could you imagine if I made you do all these determinants by hand? I could run faster than most of you.
Keyword
I could probably outrun all of you guys for like 50 yards.
Do you think so?
Yeah, that's-
You think so? That?
I know I didn't outrace you.
You think so? You think so?
Let's see. Let me give you some problems. Everybody's going to determine Kramer's rule stuff today. Steal this from you real fast. Alright, tomorrow we'll do identity and inverse things. So the 2x2s on page, let's see, this is 219. What is that now? 6 problems? All right. Questions? Someone forget about those negatives, okay? I'm just pausing.